In this video, we want to see whether the sum from n equals 1 to infinity, negative 1 to the n, of square root of n over n plus 5000 converges or diverges. First, notice that this is an alternating series, so we're going to use the alternating series test to see if it converges or diverges. So let's focus on the square root of n over n plus 5000. Let's see if this satisfies the three criteria. The first being non-negative. Clearly, this is going to be non-negative because we're looking at positive values for n, and it's always going to be positive when you add or divide positive numbers. The next one being the limit as n approaches infinity goes to 0, and that's clear because the denominator has a higher degree than the numerator, so it will go to 0. And then lastly, we want to show that this is decreasing. So if we define f of x to be the square root of x over x plus 5000, the derivative is 5000 minus x all over 2 square root of x times x plus 5000 quantity squared. The denominator is always going to be positive for positive values of x, so we just have to focus on the numerator. And when we set the numerator less than 0, we see that x has to be greater than 5000. So the derivative is negative for x being greater than 5000, which means the sequence is decreasing for n greater than 5000. All three criteria are met, therefore by the alternating series test, the series converges. The next step is to see if it converges absolutely. So we'll take the sum of the absolute value, and when we take the absolute value, the negative 1 to the nth power disappears, and we're just left with square root of n over n plus 5000. And a good guess here is to say that this will diverge because this is roughly square root of n over n, which simplifies to 1 over square root of n, and that diverges by the p-test. So what we want to do is use a direct comparison test, find something smaller that will diverge. And so in order to find something smaller, we need to make the denominator bigger. So what you could do is, I guess it doesn't matter. What we could have done instead was say n plus 5000 n to the denominator because 5000 n is bigger than 5000. But even if you put 2n here, this is going to be bigger for n being bigger than 5000. The idea is like eventually this will be much bigger, the denominator. In that case, the whole thing will be smaller. So this now simplifies to 1 over 2 times the square root of n, which this we know diverges by the p-test. So therefore we say that this sum diverges by the direct comparison test. And so the original series will converge conditionally.